So, hi everybody. Time for a conversation. So we've seen some slides, and now we're gonna do the real talk. I'm Asaf. I'm the co-founder and CEO of Iguazio. Really happy that everybody made it today. We thank our sponsors, and I believe so far it's been a great program. And we'll keep up the standard right now. What we wanted to do now, before we jump into the topics, please introduce each other. Please introduce yourself. How does your job related to ML and how ML impacts your business? Some of you can talk elaborately on the impact on the business, some less. Kishore, please start.
Can you hear me? All right. Looks like. I'm Kishore Gagrani from Dell EMC. I'll try to keep my intro very brief, but I want to introduce you to Dell technology. That's critical, because not many of the people I talk to understand Dell technology. It's an umbrella company, right? It's got 7 different companies. VMware, RSA, SecureWorks, Dell, which is your traditional laptop workstation, the compute, VirtuStream, Pivotal, and Dell EMC. So now Dell EMC, I am in the server PowerEdge. It's got Dell EMC, it's got server, storage, networking. I'm particularly within PowerEdge server, which is our server. We are world's largest providers of the server, #1, past 2 years straight. My role specifically is around server product management and planning. So I work with our engineers to plan for next generation of our servers. I specifically look into planning from the perspective of emerging technologies like blockchain, machine learning. That's where I come in here. I work with the ecosystem partners of machine learning, ISVs, specifically, like Iguazio being one of them. And my other role within the PowerEdge planning is software-defined storage, hyper-converged infrastructure. So we'll be talking a lot about it. Long introduction, sorry about that.
So you'll give us the horizontal perspective where you've been working with different customers. We'll get to that later.
Absolutely.
Michael.
Yeah. Hi, everybody. I manage the data science team at WW, which is rebranded. It's the new Weight Watchers. But if you guys are familiar with Weight Watchers, you probably don't think of it as a tech brand. But the primary touch point that members interact with sort of our services is through the app. So it's basically a data product that allows people to track their food, their activity, their weight in a way that sort of helps them meet their wellness goals. And as you can imagine, we have millions of daily active members, so we have a lot of data, especially regarding like people's dietary habits, their implicit food preferences, and how that relates to their sort of wellness goals. My team is pretty new at the company. The company sort of rebuilt itself maybe about 4 years ago, so the tech infrastructure there is really like a company that's about 4 years old. Everything's cloud native, allowed us to sort of leverage a lot of the tools that people have talked here today about, and all that being said, we focus on building machine learning models that are sort of back office. As you can imagine, churn is really important for a team that or for a company that's based on subscriptions. We also build data products like recommenders for recipes and food recommendations given people's preferences. And we also have a lot of social networking features. There's an active social network on the application, which is it's most similar to Instagram. It's just for members. It gets about 10,000 posts per hour. And we build sort of the social networking feeds that people receive. And we also build like who to follow recommenders, sort of basic social networking features.
Josh from Spotify.
Yes, hello everybody. My name is Josh Baer. I'm from Spotify. I'm the product lead for a group that we call our ML platform product area in Spotify. So I would imagine most folks in the audience are aware of what Spotify is. We have over 100 million users all over the world in over 70 countries that are listening to music and trying to connect with our application. And what we want to do is provide a personalized experience for all our users, no matter where they are. We want to give them the right piece of music for the right moment. And a lot of that is obviously done through machine learning. What our team does in particular is makes the process of building machine learning in the application to serve hundreds of millions of users easy. What we want to do is simplify the MLOps for all our engineers internally and our data scientists. So that gap that David talked about, I think earlier today, between the data scientists building the model and the production, that becomes really easy, and we're able to deploy stuff fast and learn quickly.
Jason.
Yeah, I'm Jason Evans with a company called Quadient. The company has been around total for probably more than 80 years, mostly focused in the customer communication space, all on-premise enterprise software focusing on document management, multi-channel communications, franking machines for postal mail. So we started back in August of last year with a new business idea to revolutionize the way the company interacts with its customers and the way that we can help companies leverage intelligence and data that they already have but have never consolidated or looked at it, I would say horizontally across the enterprise silos. And if I were to choose a marketing term, I would say we're building a cloud SaaS platform that will become a bridge over troubled silos.
So the topic of the panel is ML challenges, and you can allude to it already, but I would like to get now to be more specific about it. And all of you have actually taken your solutions and organizations on a journey that, obviously you improved your experiences, but why don't you take us a little bit backwards on how things were going and what you were using and how you over time improved it, and then we'll talk about the future. But let's start with the past till now. Why don't you start, Jason?
Okay, sure. Well, it's like anything else, you want to build something innovative. You have a couple choices. You can either build something evolutionary or revolutionary. Most companies don't have the appetite to jump directly to revolutionary, but if you really want to change the world, sometimes you have to just pull that trigger. So we knew we wanted to be cloud native from day one. We wanted to be as agnostic as possible to run wherever we needed to. We wanted to be able to have an MLOps pipeline that we could dynamically shift and change as we added new data, as we discovered new data both from what was happening within an organization, how their customers were interacting with their systems, but then also data that's being created dynamically, whether that's in social media, other third-party available sources, anything that may be directly related to their data or be a cohort to their data that would give us insights and information that nobody had in the conversation between the customer and the company. So we started on Amazon, and we did the traditional thing. Let's try all these different, SageMaker pieces and different database types. We knew that we were going to be 100% event-driven, so we wanted to deal with time series data, NoSQL, SQL, graphs. And we had tons of different data types and scenarios. Well, that meant that we had to use a lot of platforms. And each platform, even though if you deal with data, you know that SQL is SQL, right? Whether it's properties or if it's a standard query. But it's not really possible to create views of just the bits of data from every single one of those platforms to create some model view or collection that you can then train against. So I spent probably, 9 months with a team trying to use all these other platforms. And thankfully, I came across Iguazio, and it offered a multimodal data fabric that allowed me to store all of those data types, to operate on all of those data types using a singular API. It allowed me to deal with streams. It allowed me to trigger nucleo functions, for instance, from Kafka events or events coming from other event source systems. So it allowed me to probably, I would say at this point, we started in August, we had 9 people, we have 74 people now. I would say we probably saved 12 man-years so far. So it's really accelerating.
Thank you. Josh, different experience. I mean, I think you guys started with Hadoop and gone a long way with that, and today you're somewhere else. Tell us about it.
Yeah, we could probably do a whole talk about the evolution of machine learning.
And it's keep evolving. I mean, today is part of it.
Yeah. I think it's so to start out with a sort of a funny story of our origins of doing machine learning and on Hadoop. So way back in, I think it was around 2007 and 2008 in Stockholm, Sweden, where Spotify started, we hired our first machine learning engineer. At that time, it was probably called something quite different, but he effectively was a machine learning engineer. And he had gone rogue and installed Hadoop on everybody's machines. It's like a background process. And nobody knew about it until like at 5 p.m. when everybody was starting to leave. All of a sudden, they start to hear their computers hum. And they were wondering what's going on. And they realized like there's this Hadoop daemon running in the background. And someone was running a collaborative filtering job or something, trying to replicate, the Netflix results and build a personalized experience. And that was really the beginning of our machine learning journey. So we used Hadoop quite extensively throughout the years. We were proud. We called ourselves the biggest Hadoop cluster in Europe for a lot of like 2013 to 2016. And our machine learning practices really followed sort of that hierarchy of data science needs, the pyramid that I think someone had early on today, where we started really trying to understand, what's going on in the app, collecting data, then trying to analyze, like, what are people trying to do in Spotify? What are their needs? Once we understood that, we could start to build a more personalized product and personalize the search and personalized playlist. We came out with things like Discover Weekly, which was really a huge hit and connected people. They felt like it knew them better than they knew themselves. So a lot of our infrastructure back in that day, or a lot of the machine learning programs, were really tied to the people that built the modeling themselves, which is great until you try to scale it to a company, until people start switching teams or leaving, and then all of a sudden you're left with something that nobody knows how to iterate on or to even maintain. So as we've matured, we also have moved over to GCP, so we don't do much Hadoop anymore. We're now using a lot of data flow and other GCP systems. We've tried to standardize on the way that we do machine learning so that it becomes easy to transfer and own and maintain your machine learning applications throughout your teams. So we have a much better process now, but it's been a fun journey.
Michael.
So I had the advantage of starting with sort of a greenfield team and project. We also started with GCP and everything. There was a data engineering team at WW when I got there, so we had a data lake. Everything was sort of primed and ready to create value. So for us, we started, I came from a consulting background where I worked with a lot of larger legacy organizations and saw their data science teams. And oftentimes, especially in like the structure where you have an embedded data scientist, you would see someone working on a deployment or a project and having to recreate the work of a lot of other data scientists. I think it's really common, and I really didn't want that to happen. So we started to make like basically common infrastructure from a deployment standpoint. We ended up making our own, this is a shameless plug for our open source package called Primrose that we just open sourced recently, but it allows us to basically do really similar functionality to what we saw from Netflix, Metaflow, where basically it's a way to just have a directed acyclic graph that would sort of control all of your processes and sort of have some level of accountability at each step. And it really helped the team grow from 1 to 7 in a year and deploy all of our sort of batch-based processes, which most of what we run now is a batch-based process. And even when we do sort of real-time stuff, what this does is it fields like feature caches or model caches that then are used by our real-time APIs. But for us, it's kind of been, the year has looked like developing this open source framework, and the whole team developed it together. So it was a good learning process, different people at different sort of levels of software engineering ability, and it really kind of united the team. I encourage every team to try to build a framework. It really makes you abstract what you do and think about how everything that you do can apply to other members of the team and like really sort of reduce reduce having to duplicate code.
How big is the team now?
We're just 7, so we're a small
7.
team.
And Josh, in your case?
Our platform team's around 10 people. Throughout the organization, we have probably 100 machine learning engineers or data scientists.
And Jason, in your case?
Well, the data science team is, what was it, Sean, 6? 5 or 6? Yeah, 6.
Okay, so we had AWS, GCP, now we have Dell. We as Iguazio, we see still lots of customers that are either doing hybrid, and we're in New York, and financial services, still many of them are doing on-prem. So what's your perspective there?
Absolutely. The two different perspectives I have, right? One is Dell being such a large corporation, you would expect that we are consumers of machine learning ourselves. And we being my own group, Dell EMC server group, we have about 30 plus data scientists who analyzes our server data and feeds us back, said what's the right way to design new generation of server. So that team is an internal consumer of machine learning, right? Now, on the side where I represent, meaning provide products and offers for the market, for the machine learning, right? To Asaf's point, as we follow the Gartner's hype cycle, if you guys have anybody heard of Gartner's hype cycle, it's in a technology S-curve. Every time a new technology comes, there is a little period, then it jumps up, and then this goes in saturation. We have seen that S-curve happening in multiple technology. Machine learning, AI is one of them, and we see that's across the organization, across the industry, it's at the lower end of that S-curve. So it's ready to take off, right? When we see the implementation of machine learning, so that's my few cents to the panel here. We always see people start very conservative. Cloud gives them a good opportunity to, hey, let's go check it out, what's happening over there. Then they realize cloud is not going to solve all the problems they need. I was at a conference a few weeks ago, and a room full of people, about double the size here. We asked how many of you are planning to or have implemented machine learning training projects only on cloud. And there was one hand which went up. Everybody else said, no, we are either hybrid, meaning some of our projects are in-house, some are on cloud, but we do have a seamless connection from our in-house to the cloud, right? Or we are totally on-prem. The person who said he's only on cloud, we were specifically wanted to know their journey. And they said, well, we are a startup. We just want to test it out. And that has been for every technology you talk about, whether it's IoT edge or for that matter, any other workloads, it's the similar stuff. As they get things pretty baked in, they start talking of hybrid. Everybody has hybrid services now, right? Of course, Microsoft has yours. Google has hybrid. AWS, who was in a denial mode for many years, finally came in with Outpost. So hybrid is the way to go, and we have offering from storage point of view, which helps you put your machine learning projects on hybrid or on-prem.
That brings me to Jason. You mentioned that you had the legacy infrastructure all on-prem, and now you're kind of full out on AWS. How do you kind of bridge between the two? Are you actually doing active connectivity between the two?
Well, obviously, it's a hybrid model these days. So I would say different use cases that we're seeing with customers, there's a lot more acceptance of pure cloud, although some enterprises require that, on-premise, at least whether that's a VPN connection or if it's a event router that we place inside the organization, which essentially allows us to forward events without transmitting large chunks of data. So that's what we're seeing.
Okay. Michael, you touched upon your feature cache, which I think brings the topics, and we see different approaches where people sometimes build one kind of pipeline, one environment that deals with the data from ingestion through the exploration, training, and serving and production across one platform. How do you do it in your case? Do you separate the platform where you do the exploration and training from the production one? Because at the end of the day, you mentioned a feature cache versus a feature store where you do the exploration. Is it the same platform? How do you access all the features that you need in production?
So when we build the features to actually train the model, that same transformation would be used to write those features at the same time. So, run once an hour, every 15 minutes, those features are all available through the exact same process. It's basically, one object is passed to the next step of the pipeline, which might be retraining, and another is just sent off to be serialized. Actually, it's not even serialized. It's like written to like Redis caches, and then those are what the applications consume. But the applications are separate. Like the APIs that we write are completely separate from our pipelines. So that is one place where it's sort of like two branching pieces of code, basically.
Josh, in your case?
Yeah, so that's actually one of the more active challenges that we're trying to fix right now. And I should say, we're hiring and we're hoping people can help us fix that.
There's a recruiter downstairs. Just bring your CV.
Yeah, but it's actually a pretty interesting challenge, like the idea of building a feature store and having a way for that to be repeatable. It's a technological challenge, but it's also very much an organizational challenge because you introduce these dependencies across different teams. And at Spotify, we're very decentralized. So when you're saying, I'm going to use this feature that you produced, all of a sudden you're also saying, I'm going to slow you down because now you have to maintain that feature. So we're trying to sort of fix that organizational challenge with the right incentives, like aligning the incentives of the people that are producing features with how they're consuming. But also we just want to make it super easy to spin up these feature stores so that you can have something that you can connect to either your online serving or your batch prediction and just have a very standard setup and have that sort of, not for free, but easily available when you start out your ML journey.
Jason, in your case, I think you streamlined it all into one platform?
Yeah, well, we have multiple layers. We're creating a multi-tenant SaaS platform, but then we also have, which has a lot of batch and real-time jobs that run within each of those tenants. And then across all of the tenants, we have, I guess we'll just call it an intelligence service, where we're consuming things that are very SME specific for particular industries. We're focused on regulated industries to begin with, but building those, it's a very similar concept where we're building reusable components based on data that we sourced that fits a particular vertical, and then applying more horizontal chunks in batch jobs as we go along from that intelligence service. So at the end of the day, it is one system. It just operates in different layers. Right?
Okay. One of the things that when we talk with people about their challenges and their vision, they're saying, let's have for our MLOps a similar concept of CICD. Are you guys there yet? Are you close to that? How do you see it? You're smiling, Josh.
Well, this is probably one of the biggest challenges that we still have in addition to Feature Store, that we still are working on. Because when you have a machine learning application, you both have all the problems of a data pipeline and getting your data in the right format and reproducible, but also sort of the back-end component, matching it up with your service. So that introduces some unique challenges that we're trying to get right. And then when you add in the ability to control for quality and have sort of gates in the way to say, this model is blessed and you can go out to production. I should say we're big users of the TensorFlow extended ecosystem, and we believe like that's offering us pretty good tools to help us out with getting more towards a CICD approach. But it's still something that we're trying to get working really good. So I think as someone said it today, you have, I think David also, you have sort of that automatic pipeline. When you check in code, you can really easily go to the model deployment.
Michael?
For the pipelines, we have something similar where we've tried to design all of our libraries such that they're purely configuration as code. So we literally have the same repo, same image that's used for like wildly different purposes, and they have all different instantiations of abstractions of operations that might need to happen, and what the actual object does is dictated purely through a configuration file. So if you have that configuration file and you have some sort of general DevOps deployment platform that like keeps track of what image was deployed with what configuration, then that defines everything that could ever happen in that container. Especially because the containers are signed with a get commit hash. So basically, those three things are the full space of what you would need to recreate any pipeline at any given time, or for that matter, any model. Because the models that are created are signed with the same information, the config file, the hash, and the get commit that created them. And we just keep track of all that, and that's how our deployments are kept up to date. But on the API side, we don't really, if you make changes in the service that consumes the stuff from the pipelines, we still don't have a great solution for that. That's an open problem that we have as well.
Okay, so Kubernetes, kind of took the market, very quickly. I mean, for a technology that sits in the infrastructure. Did you see, what kind of impact did that do on your MLOps infrastructure? Josh?
Yeah, I guess I'll start. So it's interesting. We were pretty early into the container game. We actually released a container orchestration tool called Helios the day before Kubernetes was announced. So we're super excited that we built this great thing that was going to sort of revolutionize the way that people worked with Docker, and then Kubernetes came out, and that was the story. As we moved to GCP, though, we realized that aligning on Kubernetes was going to be really important for us. It also simplified our lives because we didn't have to maintain this extra infrastructure in Helios. So we started to use it a lot with our backend services, then we started to introduce it with our data. And now that we're sort of aligning on Kubeflow, and Kubeflow is using Kubernetes a lot, we're getting a lot of our learnings that we captured from understanding how to operate backend services and data in Kubernetes and applying that to machine learning. And then we also get this added benefit of you can sort of componentize your knowledge and build those into containers that you can reuse across the organization. So that's really powerful in getting us to move faster and build these applications.
Michael?
Yeah, we use Kubernetes for everything. We run our pipelines in Kubernetes, and we have our API deployments in Kubernetes. Big fan.
And then how long were you, when did you start using Kubernetes?
When did we start using it? I would say, so the whole team has only been there for like a year and a half, so our first deployment on it was probably 3 months, and so,
Oh, excellent. Yeah. This is, so Kishore, your perspective.
Wow. It's here to stay. CareKit isn't going away. We realize that we have invested heavily in Kubernetes CareKit. CareKit, Kubernetes, or containers on virtualized machine, that's a reality as well. So you guys having a greenfield scenario or brownfield scenario where you got all VMware all over, you can still run Kubernetes. What we do from our value add in that is we give you a way to deploy it right way to put a MLOps on a container, bare metal container, or in a virtualized environment. We provide that kind of guidance through our white papers or some offers, engineered solutions, right? Validated designs. There is going to be, and I cannot say when, and it's not going to be Dell, some OS components for machine learning which will be deployable on bare metal. So there will be a OS which is machine learning specific, goes right on your bare metal hardware. How many of you guys really think that machine learning can just fly in the air without a hardware? That's the, and you saw Netflix presentation earlier. Well, when it comes to data scientists, they don't think about the underlying infrastructure. If you guys really think scalability of your compute, where you run your application, and the data where it stays, scalability of that, they need to sometimes, maybe not all the times, need to stay scale at independently on its own scale. So when you're looking into a machine learning solution of any sort, you need to make sure you have a compute power and the storage that can scale independently. And whether it's a Kubernetes or whether it's a virtualized machine or bare metal operating system of some sort, planning that infrastructure for machine learning is extremely important.
So talking about hardware, that brings another point, which is GPUs. We see it, especially in deep learning application, it has been fairly used quite extensively. In your cases, Josh, are you guys using GPUs already in your applications?
Yeah, so we're using GPUs in some of the applications. I think we find I think I was doing a master's class in machine learning, and they said, we're learning all these advanced models, but in the industry, you'll actually see about 80% of the models that you build are going to be simple regressions. And I think for a lot of our applications, we do see something around that ratio. For some of our more advanced things, what we're doing, try to understand audio, extract information that we can use downstream for machine learning models. There's where we are actually seeing GPUs give us an advantage in processing things, reducing the processing time and reducing prediction time.
And Michael, your social network infrastructure, basically images, videos, are you using GPUs in them?
We have done a couple projects, but this is really at the POC phase. We're basically transfer learning embeddings that we've done on GPU-enabled machines, but we don't have anything in production using GPUs yet. It's definitely on our roadmap, but nothing battle-hardened at this point.
There's still a lot of place to grow for GPUs. I surely believe so. Back to Kubeflow. Josh, you mentioned Kubeflow, and sorry, go ahead. Sure.
I really wanted, this is hardware, I better speak something.
Mr. Hardware. So, and you had your mysterious comment about the operating system. I didn't ignore that.
Yeah, well, if you want to know the mystery, connect with me.
Okay. Mysterious. Yeah. Go ahead.
GPU. Well, it's interesting because for servers, and the statement I'm going to make is going to be a bit controversial, maybe. Depends on, I hope it doesn't put me in trouble. When we put GPU in server, it's profitable to us. So why would I say that? Why do you need GPU in machine learning projects, especially in the training? So we did do a survey. What we found out was 80% of your machine learning, especially the training projects, do not really require GPU. As long as your application can scale. So let's say if you have a distributed environment, you can scale your compute by adding another node, bringing the disaggregation of all the CPUs together, you get your application what you need in terms of compute power. One of the common thing which you get for the compute is how it is closely related to the memory in the server. I'm giving you too much of a IT or hardware stuff, but I can't resist that because that runs in my blood. But keep in mind, GPU is needed, but pay attention to what you are really looking into. What our survey said is about 80% of you don't need GPU. CPU is just fine. So please connect with us, dellemc.com/AI. You'll get more understanding of what kind of infrastructure you really need.
Thanks, Kishore. So back to Kubeflow. I mean, part of what we're doing the whole day here is around the community that has been built around Kubeflow. And I think this is a great opportunity as users to actually voice your requirements from the community. Could you think about ideas what the community should focus on?
Yeah, I think there's a few things that are at the top of our wish list or even our need list. I know I see Josh in the corner over there from Arquito. He's working on one of the really important things that we want to see in Kubeflow, which is multi-tenancy. So at Spotify, we want to build out sort of a multi-tenant cluster so that people don't have to set up the infrastructure themselves and own it. So that's really important for us. The authorization is really important. We actually have some features in our internal deployment that we would love to see be contributed back to the open source. So we have some things around caching of individual tasks that would be really useful for the open source, and also the building of components. We think that as teams start to use it more, they're going to be wanting to build components and contribute it back, and we want to see that simplified.
Excellent. Michael?
I have a mildly lame answer, but I would really like to see more sort of robust and low-level documentation, sort of beyond what they have publicly available. You can go into a lot of the code examples and find sort of much better example use cases, some of which are deprecated, but I think, you know, for my team to switch over, that would be a strong requirement to like using it completely for all of our purposes. But I'd also like to see, in terms of the actual individual containers that do operations, it seems like it's sort of ripe for an opportunity to have something similar, kind of like TF Hub, where there's like public repositories of, you know, the thousands of really, really common operations you're going to do in ML, and then, you know, ideally you would just pull from those hubs and you like just build your own small subset of nodes for your production applications.
So not necessarily just for the model. So you have like an app store for the different stages within the pipeline.
Yeah, totally.
Excellent. Jason, idea? Okay. Okay. So I mean, let's actually take it a notch up in terms of requirements. All of you are involved in all these MLOps and, you know, platforms. So again, talking and, you know, voicing requirements to the community, to the vendors, to the developers. What are the things you would like to see in MLOps that are getting solved so you can actually bring much more efficiency and impact to the business? So you want to start?
All right.
Kishore.
I'll take the... Going back to my infrastructure point here again on MLOps, what I hear from our customers is what I'm going to talk about. On Kubeflow, or how do you implement it, and that's number one requirement we get from my customers saying, give us guidance on if I had to put together a Kubeflow based, on a Kubernetes based MLOps infrastructure, what would be that? That's the number one we get. So we're working on quite a few projects around that area. On a very Kubeflow, one of the things which I heard was you get MPI in Kubeflow, message processing interface.
Okay.
I guess it's available as right now as an option.
Part of Harvard.
Yeah. We are working with Project Nota with Intel. If you guys aren't familiar with Nota, it's Intel's open source projects for deep learning. We are working on Nota, and we're discovering quite a few Kubeflow related shortcomings or gaps. So there is a list we're generating. It's all open source. Go check it out. We're also on Project Nota, actually, we're working on bringing containers native, container native and HPC together to give you a better infrastructure for machine learning training ops. So check those all out. They're all open source. Yeah.
Thank you. Michael, requirements, the folks.
So some things that have crossed my mind over the past couple of years that I think they're not sort of great tooling for an MLOps side are, one, I would say there's not great tooling for automatically serving Bayesian models of any sort. So anytime that you might want something to come back as a distribution rather than a point estimate like a frequentist type model, I think that there aren't great tools for that. So you often have to sort of build your own custom APIs. It'd be nice to see sort of automatic platforms be able to serve Bayesian models. It'd also be nice to see, along the same lines, like the idea that what comes out of an automated serving platform, like on GCP, like CloudML, allows you to just upload different flavors of models and sort of get an estimate out. But 99% of the time, every time I've ever made a prediction, the prediction itself isn't really what you want. You want the prediction with a set of Shapley values, or you want the prediction with some other processing that happens after that, like a filtering layer. And so often you'll have to build a service anyway to interact, or you might even have to build a service on the feature engineering side. So making those automatic deployment services more flexible so that more and more of your architecture can be handled by cloud providers, but at the same time adding flexibility before and after the little step that's actually producing the model prediction, I think is like kind of an open challenge and has a long way to go.
Excellent. Josh.
Yeah, so as a product person on the infrastructure side, what I really want to see is our engineers to be super efficient with using machine learning, but also to see a lot of standardization for what their practice is. On the standardization front, I'm super excited about the work that's going on in standardizing the metadata layer, aligning the community in Kubeflow and TensorFlow Extended. That's super exciting. I want to see that continue. The standardization of like complex record types is something that we're looking forward to see and supporting something more advanced than TF examples and TensorFlow Extended. On the fast feedback loops, yeah, so one of the challenges that we're faced as an infrastructure team is serving, fixing the model serving and the logging and then the feedback into the training, sort of like this continuous cycle of training. We want that to be faster, we want that to be more automatic, so we're really looking forward to seeing better tooling for that.
Excellent. Jason.
I think there's such a huge list of things that we all dream about. Oh, gee, it would be great if we had, and everything that everybody on the panel mentioned I think is critical. But at the end of the day, for me, if you can think about something, it's being able to take and visualize and operationalize that entire chain from start to finish. Like understanding where data might be relevant to a problem. So, and it's not just about finding data. It's, filtering that data to ensure that you get to a place where you can visualize from a team perspective, every role, how they can go from, I found some data, to knowing whether or not it's something they should even bother with. We spend a lot of time just evaluating and testing and trying. I think it'd be really great to get to the point where we can throw more data together, and there are a lot of solutions that are trying to do that, like from a cold lake, pre-transform data, try to understand where relationships might exist. It would help us to focus as a team on answering the real questions that we have. So that's what I'm hoping for.
So you're basically saying better visualization for the data exploration stage?
Yes, yeah. Yeah, we spend a lot of cycles just working on data that really, frankly, it's not even valid for our problem.
Okay, excellent point. So, Daniela, do we have time for questions? Yes. We do. So let's open it up. Questions? I think I asked, okay. There's a question.
It's a question for those of you who have deployed these products, Michael and Josh. Thanks. Hey, curious what you're using for model monitoring and management today, like the back end after you've deployed your products.
specifically for the monitoring of models. So we track the business metrics. Pretty simply, we do like daily roll-ups using graphs, trying to track, what are we trying to predict, or is it being accurate? So very simple tooling. That's an area that we want to explore in the future. Then, of course, we have all the traditional sort of back-end metrics monitoring. I believe we use Grafana for that.
For supervised stuff, we basically have big log scrapers. Everything goes into BigQuery. We just have daily jobs to check out the performance of our models. And unsupervised stuff, that's harder. You're aiming for KPIs for those ones.
One last question? Or are we ready for lunch? Okay, excellent. Thank you, Jason, Josh, Michael, and Kishore.